we're just going to talk through local LLMs. So you guys probably already know. Skipping slides. Come on. There we go. You already know local LLMs, large language models. That's the AI that we talk about with ChatGPT. That's the AI that we talk about doing coding work, and it's the AI. Not all of the AI that we're doing, but it's the leading edge in a lot of the AI space that people are talking about. However, we can run them locally. What does that mean? Well, when we talk about running like AIs locally, we're talking about the inference. That's the running of the AI, the answering questions, the thinking given the models already built. We're not talking about training. Training is something that requires at least $1 million in hardware, and it's not something really we're going into today. We can do some fine tuning at home, but I'm not going to talk about that. So in order to understand some of the challenges of local language models, local LLMs, you have to understand a little bit of the architecture of computers. I'm going to talk about it for 20 seconds here. Normal system on the right, you have CPU, you have system RAM. The bandwidth between them, as far as an AI is concerned, is very small. So your RAM is pretty big. You can store a lot of stuff in it usually. It's cheaper, but the communication to your CPU isn't very fast. That's a big challenge. And bandwidth is a major limitation in between the memory and the CPU of any local large language model you're running, any local AI. You often have a computer like a gaming computer where this middle one, where you have a CPU, you have RAM, they have a small link between them. There's a small link out to a GPU, a graphics processor, but that GPU has some RAM in it. And if we can load the language model into that RAM, then we have high speed between that and the GPU. And this gives us the performance you need to run a local model. This is a common use case. The problem with it is it's extremely fast, but you have a limited amount of RAM. You will spend a lot of money to get a lot of RAM. So it's common, your common gaming computer might have 12 or 16 gigabytes of RAM. At the high end, you can get 12, 24, 36, but I mean 32. When you get to 32 gigs of RAM, you're talking about a $2,000, $3,000 graphics card. You can get bigger than that, 96 gigs, $10,000. So that's where your limitations are if you're using this middle model on a standard computer. So instead, what's been really common recently is we use unified memory systems. Now, there aren't very many of these out there. AMD makes one as a special AI box. There's a couple other AI boxes. However, the big one that most people are aware of, the new Macs use this unified memory model. So the MacBook M series chips, the M4, M5, all the way back to the M1, use this unified system where they have the GPU, the CPU, and the RAM all jammed together in one place. Gives you relatively high bandwidth and relatively good performance. Not quite as high as some of the GPUs, but it's pretty close. So moving from there, so how do we understand this? Well, your RTX 5090, this is your $2,500 gaming video card. This gives you really amazing performance on it. This is an example of tokens per second speed on an LLM. However, an M5 Mac is pretty good too, right? We're getting still useful speed. So tokens per second, you really want to be over 20, 30, 40 sort of range. That's really where you're targeting to be useful. If you get down into the slow end, and this is about as high end, the bottom one down here is about as high end as you can get for system memory. So if you're running 90 gigabit dual channel 5 DDR5, which is as fast as you can buy, still really slow, so not quite good enough. That's why we talk about unified memory models. Mac M1 through M5, you can kind of see the progression, and then up to the high end graphics cards. I'm going to talk about the sizes of local language models. So we can download these. This is a complicated table. I'll sort through it in just a second. We can download different models. They have all sorts of different sizes. The ones that we run online at the bottom down here, 2 to 5 trillion what's the parameters? So 2 to 5 trillion parameters. The new one that's coming out soon, or is kind of half out, is supposedly 10 trillion. This is all cloud stuff, 100 million in hardware to run. However, we can go all the way down to a 0.2, which is 200 million parameters. And that's pretty small. In fact, it's small enough that it's almost worthless to use, but it can still function in a basic sense. And then all the way through, we have ones that will run on a budget computer. We have ones that will run on sort of a gaming computer, higher end computer. We have ones that will run on a really expensive workstation or a unified memory system like a high-end Mac. We have ones that'll run in like a data center cluster, but you could probably buy it. And then obviously these bottom ones, they're proprietary. You're never going to get a hold of them, but you can pay 20 bucks, $100 a month to use them. So one of the ways that we evaluate these is we can look at benchmarks. And so this is just a couple of examples of benchmarks. I'm not going to go into detail, but we talk about things like reasoning. We talk about tool usage. We talk about coding experience, talk about math. And so, looking at different angles, it's basically giving a test to an LLM. Give it a test, give it a score on the test, see how it does. When we compare those, because of how I'm presenting here, I can't do that. Okay, I have a website up here, but that's fine. We don't need to see it. There's a couple of benchmark sites that provide kind of an overview of these. And it's one of the ways we can evaluate local models to see which one's going to be most effective for what we're trying to solve. Because when we get to local models, one of the questions you're going to ask is, what is my use case? It's not like you just fire up Claude Opus and it can do basically everything you need, or at least to its, to its capability. It's, a lot of those large cloud models are good at everything. You don't necessarily even need to switch to choose like, oh, hey, only this one can't do images, this one can't do tools. When we get to the smaller models, you have to make those kinds of decisions. Oh, I did get a picture of this, right? So this is one of the benchmark tools, LLM stats. There's 100 of them out there, but this is one of the better ones I like. You can see where we are here. I do want to point out this new Mythos thing that's coming out from OpenAI or from Anthropic. This was just posted like 2 days ago. This was kind of brand new. Look at the reasoning score up here. Every model for the last year has been in the 50s. Mythos is posting a 72, which is kind of mind-blowing, which is one of the reasons they've restricted it so far, because it's doing things that people didn't expect and it's making people nervous. And so it's limited to 100 handpicked companies and a couple of software foundations right now, until they fix all the bugs. Because the first thing they did when they fired up Mythos is they told it to do a security audit on a bunch of common things like OpenBSD and Linux, and it found zero days that allow remote compromise of all these different systems that had been there. The OpenBSD bug's a 27-year-old bug, complete remote compromise of the system, and it found it the day that they pointed it at it. So it's a concerning thing because it's just a new arms race in this stuff. We're not talking about that anymore, though. We're talking about smaller models that have more problems because they're smaller, right? They don't have the capability. So what does it look like when they fail? I mean, we have to think about that because we're talking about small models. In a second, I'm going to show you, this is a Raspberry Pi. It's actually a 7-year-old Raspberry Pi running an AI model. And so we'll talk about what I have to turn it on here, so let it boot up. But it's got a little touch screen. It displays results on the screen. It's running actually 2 local AI models, but they're very small. So they have all of these problems. If you give it a task and tell it to go, don't come back until you finished it, it'll get stuck. I promise you. Like smaller models, they can't handle that kind of thing. They'll get lost. They'll have degraded output. They'll make up stuff. Ask it who's president. It told me that Joe Biden is the first president of the United States and his vice president is Donald Trump. All right. So that's just what happens with these really tiny models. And you get in the middle, different scales. So we're going to kind of talk about different scales here. Your frontier models, everybody knows these, Claude, ChatGPT, Gemini, Grok, Mythos. But what happens when we go down a level? This is what we call extra large models. These are ones that are run in large data centers. You still need hundreds of thousands of dollars worth of hardware to run these, but they're downloadable. You can download them. It's a terabyte of downloads, but you can actually get a hold of them. I don't know what you're going to run it on, but some of the smaller ones of these can be run on a cluster of Mac studios. Like if you get $30,000 in Macs, you might be able to get them loaded, but they won't be very fast. So these are actually pretty effective. They're often on cloud services. You can pay $2 and you can have access to some of these, and they're sort of that 90%, 95% as effective as your big cloud models. These are often the top of the line Chinese models. All 3 of these, or all 4 of these, are Chinese. That said, most of the local LLMs we're talking about are either Chinese or older. The US based cloud providers have not been releasing small models in the last few years. Don't know why. That's just kind of how it goes. So talking about the large models, and this is where it starts to get practical. You might be able to get a hold of this. Now, this is still a $8,000 piece of hardware, but if you have a high-end Mac Studio, if you have a really high-end MacBook, you can run some of these. We have Qwen, which is one of the software foundations run by Alibaba in China. GPT is one of them. This is obviously from OpenAI, but it's an older one. Llama is also run down here, a couple of different options. This Qwen 3 Coder Next is actually a small enough model. You can fit it in 64 gigs of unified RAM, just barely. You can't run anything else, but it's actually have this running at home on an old MacBook M1 that I have. So that one's kind of interesting. kind of functional for coding. I don't know that I would use it in replacement of Opus or something, but you can get some basic code out of it. It's not just basic scripting. It's actually not relatively codable, useful for code. And so this one on SWE Bench, which is the software engineering benchmark, the really common one, I think it scores in the 50s. I want to say the frontier models are in the 70s, and Mythos reportedly is in the 90s for how many problems it can solve out of the bugs that these were on, I think, GitHub. They're just a series of bugs they pulled out of open source systems. So it's not bad. I mean, it's where the cloud models were like a year and some ago. That's kind of cool. But let's talk about the ones you can run on your home. So these are ones that can run on a relatively high-end computer. If you have a gaming computer, you can probably run this. If you have just kind of an average MacBook, modern MacBook, or a Mac, maybe even a high-end Mac Mini. So these are a couple out there. Gemma is out of, I think, Google right now. So that's actually a new one of the rare new ones that's come out of there. The other ones are Qwen. Qwen is the Chinese ones. I think the Qwen 3.5 models at this scale are probably the best options. They give you the best coding, although I don't know if I'd use coding much at these sizes. You start to get into, yeah, you can write some Python scripts, but I wouldn't trust it beyond that. And this is my opinion. Some people say they use them, but it takes a lot of work to get them to work properly. But at 27 billion parameters, we're talking, it fits in, say, 32, maybe 24 gigs of memory. So your high-end graphics card, a GTX or an RTX 3090 or a 5080 or whatever that sort of range. And those are pretty effective for things like orchestration, home automation, checking your email. You can use this, like people use OpenClaw as like a thing they want to set up. This one could probably, these can run it. It's not great, it's not perfect, but it can run it to an adequate degree. Let's put it that way. And you can run it on a home PC, on a home like a large Mac Studio. Definitely don't give it coding tasks and leave it for a day. It's going to come back with a mess. But sometimes we need smaller. So again, this is into the sort of there's 6 billion to 12 billion size. Qwen is another one that's a top. Qwen 3.5 came out like 3 weeks ago, I think, 4 weeks ago, and all of them all the way down the scale are pretty near the top of their given sizes. So this is where this one will be able to check your email. It'll do home automation stuff. You can run it on a kind of an average PC. They fit in sometimes 8 gigs of RAM. So even like an old gaming PC you're not using anymore or something, this can be an option. Fire up Qwen 3.5 9B and you can let it go and see how that's working for you. Sorry, I got a pop up over here. Oh, come on. It's trying to invite me. There we go. Okay, so extra small. What do we do with Raspberry Pis? What do we do with embedded devices? This is a niche use case right now, but it's an interesting experiment and a thought experiment. You can load this on an Android phone. You can load these on a Raspberry Pi. You could probably load this on modern Wi-Fi controllers. Like there's all sorts of things that could run this. You need 2 gigs of memory, maybe 1 if you're really tight. And you can get useful models out of this. Again, Qwen 3.5 is kind of your benchmark. There's even a 0.8. There's 800 million parameters, and this one's useful. That's what I have loaded on this box. I'll show you in just a second. In order to get through this real quick, I'll show the hardware off in a second. Come on. Why are we not flipping? There we go. Real quick, if you're looking at local models, they will often be quantized. What that means is they've taken the 16-bit precision that the original model is written in, and they've reduced it to 8, 4, sometimes even 1. And so this can be useful to shrink the models. Most people find that around Q4, which is the 4-bit quantization, and Q4KM is the most common one, which is a Q4 with a special encoding and a medium size. That's where most people, if they're looking to run the most effective model possible, but fit it onto some local hardware, Q4KM is what to look for. If you want to try out a really big model and jam it into some smaller hardware, sometimes the IQ1, I mean, there's going to be more hallucination when you go down in quantized size. It's going to have more of the problems that we talked about, but the capabilities, like the ability to use tools and things, are often preserved. So you end up with the ability to do things, the willingness to do things, but more of the sort of hallucination and kind of weird responses from the quantization. So there's trade-offs there, but that's where Q4, if you're really trying to get like the Qwen Coder 80B can fit in 64 gigs of memory at Q4. Whereas if you have it at FP16, it's 160 gigs or something like that. Cool. Couple of pieces of software that you're going to use if you're trying to do this. Most common LM Studio, Olama, are what most people run. There's a couple others. So LM Studio is a GUI, works in Windows, Linux, Mac. Olama is command line. In fact, LM Studio runs Olama under the covers, but LM Studio is a really nice GUI to do a bunch of things for you. LM Studio is also tied in, can be tied, or either of them can be tied into Open Web UI, which is a way to expose your LM to a web interface. It loads on 8080 or whatever, and then you have a nice website that looks like ChatGPT, where say you expose it to your company and everybody can log in and type their queries into it. You can also harness framework these into coding. So you guys probably heard of Claude Code if you've done any AI stuff. Claude Code isn't an AI. Claude Code is just a programming framework. It's a harness. It's a local piece of software you run that has an API to their AI, but it's locally running all of the harnessing for that. So it has a bunch of tools. It has a bunch of prompting. There's system prompting, other things. There are other versions of it, Open Code, Cursor, a couple of others that are out there. So if you want to use something like Claude, you can actually hack Claude Code to use local AI models. Problem is their system prompting is kind of tailored for Opus and Sonnet, so it doesn't work great with local models, but some of these other ones will work better for that. So like Open Code is a common one. And some of these are built into Open Code is actually one that's built in. It's built for Open Code, which is a cloud platform that has all of these models in the cloud and at different prices. So you can load any one of the ones we just talked about to try it out. Some of them are even free, the smaller ones, with a limited usage. And then they'll go all the way up to the big ones like the Kimi and Minimax and KLM and some of those big ones that you can try as an alternative to cloud providers that are a tenth the price of the Anthropics and ChatGPT sort of levels. And I think that's it. So I'm going to leave this here real quick. What I built just for this today, just yesterday, I thought it'd be fun to have something here. This is a 6-year-old Raspberry Pi with a touch screen on it. It just has a little record button. I can press it. I can ask it questions. The model will respond. How are you doing today? And if you want to check it out, it's thinking right now because it's running. So this is running the 0.8B. First of all, it's running a small model that does voice recognition. And some of those are really tiny. I think it's 200 million parameters. And then it's running the 0.8B Quinn 3.5 locally using Olama and then displaying it on the screen. So I said, how are you doing today? And it says, I'm processing your query and waiting for the next prompt. So my current status is not known yet. Please ask me something else. Okay, great. You can ask it questions. What's the capital of France? And it'll respond Paris. But if you ask it like, who's the prime minister of France? It's probably going to tell you like somebody, who knows? Like it's really not good at current events. There's no web interaction. This is like offline, but also its hallucination rate is really high because of it's such a small model. It fits on like 500 megs of memory in Raspberry Pi. So this battery will last for about 20 minutes when it's doing AI, and it'll heat up and start thermally throttling because it's not designed for that, but hey, it'll work, right? And this is the kind of proof of concept. You could put this in an iPhone, you could put this on an Android, whatever. So that is where we end.